Hello everyone, this is the solution video to AMC8 mock test. Let's do question 1. Which of the following number can replace the square in this fraction so its value is between 5 and 6? We can simply multiply 7 everywhere to get 5 times 7 is less than the square is less than 6 times 7. So this missing number is between 35 and 42. Let's check every number in the choices. It's easy to see. The only valid number is 37. So the answer is C. Question 2. Johanna walks for 10 minutes. The following is the graph showing her elevation in meters versus time in minutes. The question is how many minutes she was walking uphill. So she was walking uphill means the elevation is increasing. So let's check which parts of the graph have the elevation increasing. So it's easy to see the first 3 minutes, the elevation is increasing. After that, we have elevation doesn't change. Later, the elevation decrease, and then the elevation doesn't change. Finally, for the last 2 minutes, the elevation is also increasing. So we just add all these two pieces. So this first we have 3 minutes, last we have 2 minutes. So the answer will be 3 minutes plus 2 minutes, which is 5 minutes. So the answer is B. Question 3. Naomi has a broken calculator. You can only do either adding 1 to the previous answer or square the previous answer. Now the question is Naomi start with 2, and in how many ways she can obtain answer of 20? Now this question is better to work backwards. In other words, the question is equivalent to in how many ways can we start from 20 and get back to 2, following the rule here. Now let's see, if we start from 20, 20 can only be obtained by adding 1 from 19, because 20 is not a square. So 20 comes from 19. And same, 19 comes from 18. 18 comes from 17. 17 comes from 16. So that's the only choice. But when we arrive at 16, we should be careful because 16 is a square number. It could be achieved by 2 different ways. The first way is from 15. 15 plus 1, 16. And there's a second way because the calculator can square the previous answer. So 16 can come from 4. By squaring 4, we get 16. Okay, now we have 2 branches. So we can apply similar discussions to these separate branches and check how many ways. Okay, let's apply similar argument. For 15, we just reduce 15 by 1, 14, 13, up to the next square number. We know that number is 9. So from 15 to 9, there's only one way. But for 9, there are 2 ways because 9 is a square number. So it can be either obtained from 8 or from 3. 8 plus 1 or 3 squared, right? And then for 8, we reduce 8 to 7, 6, 5, 4. That's the unique path. But for 4, we have 2 ways, either from 3 or from 2. 3 plus 1 or 2 squared. Now for 3, so we got 2 by subtracting 1. 2 is already there. Okay, so for the next part here, 3 comes from 2. So next, let's consider the lower part. For 4, 4 is a square. 4 is a square, so there are also 2 paths. One is from 3, 3 plus 1, 4, or 4 comes from 2 squared. So for 3, it comes from 2. That's the only choice. So in total, we see there are 5 different paths. So the answer to this question is 5. Question 4. For how many positive integers n between 1 and 10, this expression is not a perfect square. Let's think about what kind of n make this to be a perfect square. So n to the power 3n is a perfect sphere for two different ways. The case one, n is a perfect square. This a perfect square with any power becomes a perfect square. So this case, we could have n to be 1, 4, 9, right? Or case 2. N is an even number. Because here the power is 3, and if n is even number, the power is even. So as long as the power is even, this number is a square. So combine these parts, we can answer our question. So n to the power 3n not a perfect square. We need to have n to be odd number and not a perfect square. So we could have n to be odd number but not perfect square. So 1 is not valid, 3 works, and 5 works, 7 works, 9 doesn't work. So there are totally 3 cases. The answer here is 3. Question 5. A square piece of paper is folded along the diagonals twice and a corner was cut. Now, which one is the result when the paper is unfolded? So here we can also do backwards. We check every picture and see what kind of cutting make this picture. For example, for A, let's just draw this 1/4. So you connect the center to this one and this diagonal. So that shows when it's folded twice, this should be the shape. Okay, that's actually the answer to this question. Now let's check other choices. For B, in order to get a picture like B, we need to cut in the following way. We fold it twice. The shape is here, so we should cut this way. That's not answer, of course. For C, similarly, you see there we need 2 cuts actually for C. For D, let's connect the center and these 2 diagonals. We also need 2 cuts in this way, get a pentagon. And for E, this is a different pentagon. So it's easy to see the answer should be A. It's because that matches this figure after cutting. Question 6. Benjamin and his classmates arranged in the grid are standing at the playground. Each row has the same number of kids. Now Benjamin's position is second from the front, third from the back. So there are a couple of rows. Let's see, from the front, Benjamin's row is the second. So Benjamin is here on the second row. And the third from the back. So that means there are 2 rows behind. Now we consider how many kids in each row. There are 2 kids on the left and 3 kids on his right. So there are 2 kids on his left and 3 kids on his right. So we see that totally each row, there's 6 kids. Because we have totally 4 rows, so the answer is 6 times 4, which is 24. The answer here is D, 24. Question 7. How many 6-digit integers of the form AB, AB, AB are multiples of 12? So we see the pattern is AB repeated 3 times. So accordingly, this corresponds to the 2-digit number AB. Maybe let's put this line here, means 2. Okay, means that's a number. It's the 2-digit number AB times 10101. This is divisible by 12. Note that 12 is 3 times 4. We have that 10101 is odd, means it's not divisible by 2 or 4, is a multiple of 3. because the sum of digits is 3. So it's divisible by 3. That's already guaranteed. We need to make sure the number is divisible by 4. So we require this 2-digit number AB is divisible by 4. In other words, AB, this 2-digit number is 3 times a number, is 4 times a number, 4 times K. So it's a 2-digit number. So we must have K to be, it's at least 3, 4, 5, up to 24. Otherwise, it's too big. So the answer is 24 minus 2, we have 22 kgs. So the answer here is 22. Question 8. The diagram shows a regular pentagon inside a square. What's the value of x? So let's review the angles in general angle. So for the general angle, that is a polygon with own sides, the total angle, the sum of all angles equals n minus 2 times 180 degrees. The idea is that this regular angle can be split into n minus 2 triangles. So that's why the total angle is n minus 2 times 180. And a special figure is the regular angle. Regular angle. That means every angle has the same value. That implies we have the each angle is the total angle, the total sum of angles divided by n. Okay, let's come back to this question. Here we have a regular pentagon. Here n equals 5. So we can calculate each angle. So each angle equals, okay, 5 minus 2, that's 3. 3 times 180, 540, and then divided by 5. We got an angle to be 108. So each value here is 108 degrees. 108. Sorry, 108. Now we're looking for the angle x. So we can view in this way. I will know this angle to be angle 1, this angle to be angle 2. Now let's add these 4 angles. 108 degree plus angle 1, that's plus angle 2 plus, and 108 degrees plus angle x. Okay, 5 angles. We see that these 5 angles, the first 2 angles add up to 180 degrees. And the last 3 angles add up to another 180 degrees. And also the angle 1 plus angle 2 add up to 90 degrees. So we see that the sum is 360 degrees equals 108 degree plus 90 degree and plus 108 degree plus x degree. So we can solve x equals 54. So that's the answer here. Question 9. A sequence of 7 positive integer numbers has average, median, range, and the unique mode all equals 7. What's the least possible value of the largest number in the sequence? So the here answer is 9. Let me basically give you this example. The median is 7, so the middle number is 7. Largest number 9 works. Accordingly, the smallest number should be 2 because the range is 7. Now let me fill in the missing numbers. This here is 7, 7. Here's 8, 9. So 7 is the unique mode. The sum is 49, so the average is 7. So it works. So we also claim that smaller number does not work. Smaller numbers do not work by a very basic argument based on the average. So for example, we just need to work on 8. Let's show 8 doesn't work. So let's work on 8. If the largest number is 8, because the range is 7, so the smallest number is 1, and the median is 7, so the middle number is 7. Let's see, because average is 7, that means the sum is 49. Sum is 49. Now we can consider the other 4 missing numbers. So the sum of the 4 missing numbers is 49 minus 1 minus 7 minus 8, so which is 33. And their average is 33 over 4. It's already larger than 8. That's not possible, because we have the largest number equals 8. So the average of other 4 numbers cannot be larger than 8. So the answer is 9. Question 10. Find 6 of kids in the room were boys. After 30 boys left, 80% of the remaining kids were boys. The question is how many kids were in the room at the beginning. Well, let's just assume there were X kids in the beginning. So we set up this table. So boys takes 5 over 6x, and the total initially there are X kids. At the beginning. Now after 30 boys left, we have boys equals 5 over 6x minus 30. The total number of kids is x minus 30. It says that the percentage of boys becomes 80%, which means 5 over 6x minus 30 is equal to x minus 30 times 80%. Well, 80% is basically 4 over 5. So this is 4 over 5 x minus 24. Now these two are equal. We can solve x. So 5 over 6x minus 4 over 5x equals 30 minus 24. That basically equals 1 over 30x equals 6. So we can easily see x equals 180. So the answer here is 188. Question 11. Each of 4 friends, A, B, C, D, pick a number, and there are 4 statements. How many of the 4 statements were true? Let's check their statements. A said to B, your number is greater than mine. Okay, we don't know if it's true or false. Maybe true, maybe false. Maybe true, maybe false. Now let's check B. B said to A, that's not true. So if the statement of A is not true, now B is true. If the statement of A is true, now B is false. So for A and B, we must have one statement to be true, the other one to be false. Okay, if we go to C, C said, you are both wrong. Okay, C can never be true. So C is always false. And D says, you're right to C. So D should be false. So in either way, we always have just one true statement. So the answer here is B. Question 12. 5 squares and 2 right triangles are arranged in this picture. So these two black one, these two white blank ones are right triangle. And we know the area of 3 squares. We need to find the area of this square with question mark. This is related to Pythagorean theorem. So Pythagorean theorem says that for a right triangle with side lengths A, B, C, so A and B are two legs. Now, if you draw, we have the Pythagorean theorem to be A squared plus B squared equals C squared. Now we can view these numbers in geometric meaning. In other words, this A squared corresponds to the area of a square with side length A. So we can draw a square with A. So A squared means the area to this direction. So B squared corresponds to the area of square with side length B. So this B squared means the area. Similarly, for C squared, that's this largest square. In other words, the sum of these two smaller areas equals the largest area. This applies to our question here. We can look at this model. We would have the largest square to be 3 plus 22 equals 25. So the middle square has area 25. Also, if you look at the right part, similar argument, we have 25 equals 8 plus this question mark. So accordingly, the question mark has the value 17. So 17 is the answer here. Question 13. The public holiday is always celebrated on the third Wednesday of a certain month. In that month, the holiday cannot occur on which of the following days? Let's find the requirement of that day. So it's on the third Wednesday. Now, suppose the date is N. Accordingly, we can check the second Wednesday. That corresponds to date N minus 7. And the first Wednesday is going to be N minus 14. So N minus 14 is the first Wednesday. That cannot be too small, cannot be too big. So this number should be at least 1, but at most 7. If it's larger than 7, it cannot be the first Wednesday. There will be a Wednesday before it. So that's the requirement. Accordingly, we have the requirement for the N is larger equal to 15 and less equal to 21. By checking these choices, we see 16, 18, 19, 21. They are all possible. The only date that's not possible is 22nd. So the answer here is E. Question 14. A sector of a circle has radius 1 and area 1. What's the arc length of this sector? So we can view the sector as a part of big circle. Let me draw the complete circle. And we can consider the corresponding central angle is theta. So the fraction is theta over 360 degrees. That applies to both the area and the arc length. For example, for the area, it's 1 over pi r squared. This corresponds to this fraction theta over 360 degrees. Second, let's consider this is area. Let's consider arc length. Let me mark this arc length. I will call it L. This is something to be solved. So L is the arc length of this sector over the whole circumference is 2 pi r. Is also the same fraction. Now, using these two equations, we can solve the arc length. So 1 over pi equals L over 2 pi. So L equals 2. The answer here is 2. Question 15. Hexagonal paving stones are laid to form continuous paths across a round. This path is bordered by lengths of wood, one for each side of paving stone, not touching another paving stone. If there are totally 98 pieces of wood used, how many paving stones are used? Let's assume there are n stones. Used. And let's count how many woods are used. First, we know the total size, total number of sides. That corresponds to 6 times n, because every stone there are 6 sides. But not every side we have a piece of wood used. The place that is not used is when 2 stones touch. 2 consecutive stones touch each other at one side. So we have totally n stones. That means total touching is n minus 1. That corresponds to, because each touching is 2 sides, they touch each other. That corresponds to 2 times n minus 1 sides without wood. In this way, we compute how many sides we have wood, which is 6n minus the side without wood. This corresponds to 98. And accordingly, we have 4n plus 2 is 98, so n equals 24. The answer here is C, 24. Question 16. There are 2 groups of numbers. For group 1, there are n numbers with average equals 8. So we can compute the sum equals 8 times n. Also for group 2, there are n numbers, but average is 20. So the sum is 20n. For the total, the group average becomes 16. And we have totally n plus n numbers. So we can see that the sum of group 1 numbers plus group 2 numbers equals the total numbers. In this way, we can find the ratio from n to n. So accordingly, we have 4n equals 8n. That means m to n equals 1 to 2. The answer here is D. Question 17. A cylinder has a height that is twice of the radius of its base. Cut it into 2 cylinders. If the volume of the larger one is 5 times the volume of the smaller one, what's the ratio between the surface area of the larger one and that of the smaller one? So let's do a review for the volume and the surface area for a cylinder. Let me do a review here. For a cylinder, we have 2 crucial numbers. One is the radius of its base, r. One is the height. So we have the 2 very fundamental formulas. First is the volume. It's the base times height, base area times height. So it equals pi r squared times h. And also we have the surface area. There are basically 3 parts: the top circle, the bottom circle, and the lateral side. So totally we have 2 pi r squared. That's the sum of 2 circles. plus 2 pi r h. So this is the surface area formula. Now we come to our question here. Here we have the height as twice of the radius. So here we only consider ratio, so we can just assume the radius to be 1 and the height to be 2. It doesn't change the ratio here. Now we know that we got two cylinders. The larger one has volume 5 times of the smaller one. So if we have H1, H2, we know their ratio. So H2 is going to be 5 times H1. But we know their sum is 2. So we can solve H1 is 1/3. H2 is 5/3. All right, using this data, we can find their surface area. So let me call smaller surface area, which is 2 pi r squared plus 2 pi r times the height, which gives 8/3 pi. That's the smaller cylinder surface area. Now we consider the bigger surface area. Two pi r squared plus 2 pi r times the height, which is 16/3 pi. So we can find the ratio of their surface area. 16/3 pi to 8/3 pi. The answer is basically 2:1. So we choose B here. Question 18. On the 3x5 chessboard, the counter can move one square at a time along a row or a column, but not along any diagonal. Starting from some squares, it can visit each of the other 14 squares exactly once, without returning to its starting square. Of the 15 squares, how many could be the counter's starting square? So let's check which square works. For example, we can check the corner square. Suppose I start from the corner. Let's see if the counter can visit all other 14 squares exactly once. That's no problem. You can go this way, go this way. So the counter visits every square except once. So this corner square works. Similarly, we can check other corners. So this also works. Similar type, similar path. So these 4 squares are valid squares, valid starting squares. Now let's check other squares. For example, if we start from a square next to the corner, it will not work. For example, it goes this way. Okay, but we missed one corner square, so it doesn't work. You can try other approaches, but it doesn't work. And then we check the second type of square that works, which is the middle square of the first row. So it's not hard to see the valid path. It's of course not unique. So this works. So this type of square works. Similarly, the third row, the middle square also works. They are of the same type, right? And the third type of square will be here. So we can easily draw some valid path without difficulty. So this square works. Similarly, the square on the right part also works. So in total, we have 8 squares. They are valid starting squares. The answer here is 8. Question 19. Jack is making a darts target as follows. The small circle has a radius 1 and the largest circle has a radius 3. If you want to place point PQ on the largest circle so that the probability of dart hitting the two shaded regions are equal, what should be the central angle POQ? Let's assume the central angle POQ to be theta. We're going to solve theta, right? Here now the requirement is that these two, the probability of dark hitting these two shaded regions are equal. That basically means they have the same area. Let me call this area 1, this area 2. So we basically have area 1 equals area 2. That's what it means. The probabilities are equal. And now these two shapes are not so regular, but we know that if we add this part, let me call it 3, this sector, it becomes regular. So that implies 1 plus 3 equals 2 plus 3. In other words, a small circle equals a larger sector. Let's solve the theta in that way. So basically we have a small circle as radius 1 equals, radius 1, a larger sector with central angle theta and the radius 3. That's given in the question. They have the same area. Now, by the formulas of this circle or sectors, we have that pi r squared equals theta over 360 degrees times pi r squared. Okay, then we can solve this theta. This theta is 1 over 9 of 360 degrees. So it becomes 40 degrees. So the answer is C here. Question 20. Positive numbers are arranged as follows. The first term happens at number 2, the second 3, the third 5, and so on. The picture shows. What's the number on the 45th term? And we note that there are 4 directions of turning. For example, in the first direction, we have like 2, 10, 26. In the second direction, they are 3, 13. And in the third direction, they are 5, 15, 17, right? In the fourth direction, 7, 21. So there are 4 directions. Let me mark the direction. 2, 3, 4. So the direction is a 4 cycle. So that the direction of turning is 4 cycle. That means after 4 times, it goes to the same direction again. So in order to find the 45th term, what's the number there, we need to determine which direction is the 45th term belongs to. 45 is congruent to 1 mod 4. That implies 45th term is in direction 1. And let's see which number in direction 1 is 45th term. Because the turnings are is 4 cycle, that means 45th term is equivalent to 12th term in direction 1. Okay, and now let's check the pattern in this number. And it's easy to see that the number before the turning number is a square number. Like 2 before that is 1, 1 is a square number. 10 before that is 9, 9 is a square number. 26 before that is 25, it's a square number. Now the pattern is easy to see. The pattern is the following: is 1 square plus 1, that's the first number in this direction, first turning number in this direction. Then 3 square plus 1, the second turning number in this direction. And the 5 square plus 1, that's the third turning number in this direction. Okay, we are looking for the 12th turning number in this direction. So 12th, by checking the number here, we see that this 1, 3, 5 corresponds to the odd numbers. The first number is the first odd number, second is the second odd number. So for the 12th odd number, the 12th odd number is going to be 12 times 2 minus 1. So that should be the square here, 12th odd number. And according to this pattern, that number should be the square plus 1. So it's 23 square plus 1. And we see that the number equals 530. So the answer is 530. Question 21. A, B, C, and D are 4 vertices of a trapezoid in this coordinate system. They are already drawn in this picture. E is a point on the x-axis between C and D, such that the area of ABE is half of the area of ABCD. What is x? Now let's find the total area first, because we know all 4 vertices of the trapezoid. For the trapezoid A, B, C, D, let me use bracket, means the area. It is equals 1/2. The top base here is 2. The bottom base is 4. And the height is equal to 8. So the area equals 24. So that means the triangle ABE has half of the area, which is 12. But the difficulty is here, for triangle ABE, the sides is tilted. So it's not easy to see the height, the base. So in this question, let's try to do the other part, the complement part. That is 2 other triangles. The other part is also half of area, so it's 12, which is triangle ADE, the area, plus triangle BCE. They are both right triangles, so it's easy to find the base and heights. For triangle ADE, the base here is x plus 2. And the height is 4. Now for triangle BCE, the base is 6 minus x. And the height is 2. And then that's equation on x. We can go to solve x. This is basically equals x plus 10 if we simplify. Now x plus 10 equals 12. Our conclusion is that x equals 2. The answer here is 2. Question 22. 2 friends set out at the same time, each walking at a constant pace. One person travels from A to B, the other from B to A. They meet at noon, non-stop all the way, and arrive at their destinations at 4 p.m. and 9 p.m. respectively. What time do they set out? So let me call these 2 persons to be 1 and 2. And for person 1, we assume the speed is v1. For person 2, let me call the speed to be v2, okay? So person 1 start walk from A to B, and person 2 from B to A. Now they meet at a point at a time at noon. So let me call this point to be N. Suppose they walked T hours in the morning. They walked T hours in the morning. So the morning distance for person 1 should be v1 t. The morning distance for person 2 should be v2 t. Okay. And now after that, they have the afternoon walking. For person 1, afternoon walking, it takes 4 hours. He arrived at the destination at 4 p.m. So this is 4 hours. For person 2, it takes 9 hours. That's the background. So we can actually find based on their time, we can find the ratio of their speeds. For example, for first person in afternoon, the total distance is v2t, which is the distance walked by the person 2. So for this distance over the speed, the person 1 speed, that is 4 hours. And for person 2, the distance is v1t in the afternoon divided by corresponding speeds. That's the 9 hours. So we know the ratio here is 4 to 9. So basically we can cancel t. So that means v2 over v1 to v1 over v2 equals 4 to 9. Now we can find that v1 to v2 is basically 3 to 2. Okay, so that's their speeds. Now we can use this to find the time they spend in the morning, and accordingly we know their starting time. So let's take a person 1. For person 1 in the afternoon, the distance walked is v2t. In the morning, the distance walked is v1t. The speed doesn't change, right? So v1t, the ratio of the speeds is the ratio of the distance is equivalent to the ratio of the time, which is t over 4 hours. But we know v1 to v2 is 3 to 2. So that means we can solve t. T is going to be 3 over 2 times 4, which is 6 hours. So for the first person, he walked 6 hours in the morning. So the answer is 12 because they made at noon. 12 minus 6, which is 6 a.m. They set out at 6 a.m. That's the answer speed. Question 23. ABC and AD are both right triangles with angle B, angle D right angles. These are points on AB, so AD is 14, BE equals DB equals 4, BC equals 10. What's the area of ACE? Now, we can use cut and paste to express the area of ADE by some irregular shape. But here, it's important to find this intersection CE with AB. Let me call it F. To solve F, we can use similar triangles. It's easy to know that triangle EDF is similar to triangle CBF. Based on the common ratio, we have DE over CB equals DF over BF. We know the ratio is 4 to 10, which is basically 2 to 5. And accordingly, we can solve DB, DF, and BF because we have DB is given, that is 4. So that implies DF equals 2 over 7 times 4, which is 8 over 7. And BF is 5 over 7 times 4, which is 20 over 7. Now, based on that, we can solve the shaded area using cut and paste. Let me put here, ACE, this area can be viewed as triangle ABC plus triangle ADE, but we subtract this unshaded part, BCF, and add this triangle DEF. And we know all the data, we can plug it. So for triangle ABC is 1/2 times 18 times 10. And triangle ADE, that's 1/2 14 times 4. Now triangle BCF, subtract 1/2 times 10 times 20 over 8, we just solved 20 over 7, right? And plus the small triangle DEF, 1/2 times 4 times 8 over 7. Yeah, that's basically our calculation. If you simplify it, we got an answer. The answer is 106. Question 23. Here, let's do another method using cut and paste. We are going to extend CB by 4 to a point, let's call it F, and then connect EF. So in this way, we have the square DEFB. It's 4 by 4 square. And then the shaded triangle can be viewed as a part of the quadrilateral CAEF. Let's write down the area ACE is part of the big quadrilateral AEFC with this unshaded part, triangle EFC, removed. Now for the quadrilateral AEFC, it consists of 3 parts. Triangle ABC, it's a right triangle. Triangle ADE, another right triangle. And the square BDEF. Minus EFC. Each part is easy to compute its area. So ABC is 1/2 times 10 times 18. ADE is 1/2 times 14 times 4. The square is just 4 square minus EFC. So 1/2 times 14 times 4. And this equals 106. It is the answer. Question 24. In triangle ABC, DE are midpoints of AB and AC. F is the midpoint of AD. And G is a point on AE such that AG to GE is 1 to 2. HI at a point on BC, so FI is parallel to AC. GH is parallel to AB. The area of triangle ABC is n times of the area of the shaded triangle. What is n? So let me mark this vertices of this shaded triangle to be, say, x, y, z. Let me call this x, y, z. Now we're looking for the ratio of the triangle, the area of triangle ABC and the x, y, z. So it's easy to see they are similar because the sides are parallel. For example, we have xz is parallel to AC, xy is parallel to AB, and yz is parallel to BC. So easy to deduce that triangle x, y, z is similar to triangle ABC. So we need to find the ratio of their side lengths. So the area of triangle ABC over the area of triangle XYZ is the square of the ratio of their side lengths. For example, it's the square of YZ, larger one, okay, BC over YZ. Now let's find this ratio using the given information. All right, so notice that we have DE are midpoints, right? So first we have triangle ADE is similar to triangle ABC. And because DE are midpoints, we have DE over BC is equal to AD over AB, which is 1/2. In other words, DE is 1/2 of BC. We're doing this because YZ is a part of DE. So we try to connect those lengths. Now we know DE. So next, let's see what fraction of DE is YZ, right? So first we note that F is the midpoint of AD, so FA equals FD, and FZ, actually FI parallel to AC, so we have FZ parallel to AE. So that just implies DZ is 1/2 of DE. Okay, let me box this key equations. And next, we consider, because GY is parallel to AD, is parallel to AD. That implies similar triangles. Triangle EGY is similar to EAD. Okay, because we know the location of G, we can find the location of Y accordingly. So AG to GE is 1 to 2, that's given. This also implies DY to YE is also 1 to 2. So we know the location of Y. That means DY is 1/3 of DE. One-third of DE. All right, in this way, we can find the YZ now. Our conclusion is that YZ is DZ minus DY. Now we know DZ is 1/2 of DE. And the DY is 1/3 of DE. So this is a 1/6 of DE. 1/6 of DE. But we know DE is 1/2 of BC. So YZ is 1/12 of BC. Accordingly, we know this ratio, right? So we know BC over YZ equals 12. And the answer here is N, right? N is this square. So N is basically 12 squared, which is 144. So our answer is 144 here. Question 25. Has 3 regular dice, what's the probability that the product of these obtained values has 8 distinct positive factors? Now, this question concerns probability and also the number of factors. Let me review the formula related to number factors. So for a positive, okay, let's review. For a positive integer, let's see n, we have the prime factorization. Prime factorization. Say it's equal to n equals some prime p1 to the power alpha 1, p2 alpha 2, pl, say alpha l. That's the prime factorization. Now p1, p2, pl are different primes. Now the number of factors can be calculated in this way. N has 1 plus 1 times alpha 2 plus 1 alpha l plus 1 factors. That's the formula. Now we can take an example. For example, if we take number 360, we can do prime factorization. It is equal to 2 cubed times 3 squared times 5. We can view the power of 5 to be just 1. So it has 3 plus 1 times 2 plus 1 times 1 plus 1 equals 24. So 360 has 24 factors, positive factors. Now let's come to this question. For this question, we got 3 numbers, each from 1 to 6. And the product has 8 distinct positive factors. So, because this is probably a question, we can consider how many total possibilities. So total number of outcome is 6 cubed, which is 216. Because each die has 6 choices, 6 results. So 6 cubed, 216 cases. Now we need to consider how many valid outcomes. So let's check the valid cases. Let's say the product N has 8 distinct positive factors. 8 factors. Now we know that the number of factors is computed in this formula. So let's try to factor 8. So 8 can be factored into, it's just 8 itself, but in our case, it's not possible because we cannot have product to be a number to the 7th power. So here we have 2 valid cases. That's 2 times 4, or 8 equals 2 times 2 times 2. Okay. So we would discuss these 2 cases. So for 2 times 4 is basically 1 plus 1 times 3 plus 1. That means there are 2 prime factors. The powers are 1 and 3. If it's 2 times 2 times 2, it's 1 plus 1 times 1 plus 1 times 1 plus 1. That means there are 3 different factors, different prime factors, each with power 1. So we would like to discuss these 2 cases. Case 1, this product has the form P times Q. Okay. Now we know that these 3 numbers are from 1 to 6, right? The prime numbers are only 2, 3, and 5. So let me mark here possible prime numbers are 2, 3, and 5. So we would discuss different scenarios to get P times Q cubed, and PQ are 2 primes. The case 1, case A, for example, case A. So it's 2 cubed times 3. Case B is 2 cubed times 5. Case C is 3 cubed times 2. We cannot have 5 cubed, otherwise every number should be 5, but that's not our case. So we only have these 3 cases. Now for each case, let's discuss how many ways to get that product. For case A, 2 cubed times 3. This 3 number could be a permutation of 1 or 6, and a permutation. And or it could be 2, 2, 6. Or it could be 2, 3, 4. We will take the permutation into consideration later. Now for 2 cubed times 5, the only possibility is 2, 4, and 5. For 3 cubed times 2, the only possibility is 3 times 3 times 6, because every number must be divisible by 3. Right? And next, let's consider case 2. Case 2, the product equals the product of 3 prime numbers, say P, Q, R, PQR prime. So P, Q, R, R prime are different primes. Different primes. So like here, P, Q are different primes. Right? Okay, we discussed how many cases. So because we only have 3 different prime factors, 2, 3, 5, so the only possibility is n must be 2 times 3 times 5. That's the only possibility. And there are 2 possibilities to get this product, either 2, 3, 5 or 1, 5, 6. So now we list all 4 possible scenarios, the total value of the cases. Now for if 3 numbers are distinct, we have 3 factorial. If there are 2 numbers same, we have 3 cases, the permutation. Here we have 3 factorial. Here we have 3 factorial. Here we have 3 cases. Here we have 3 factorial. Here we have 3 factorial. So total number of cases is there are 2 3s, but there are 1, 2, 3, 4, 5, 5, 3 factorial. So totally we have 36. Now the answer is this number over the total number of outcome, which is 216. So the answer is 1 over 6. The question has answer E here.